In this lesson, we're going to be solving systems of linear equations by graphing. So the directions will say solve, and here is our first one. Our first equation is y equals 2x minus 5. Second equation is y equals negative 1/3 x plus 2. Now they're both ready to graph. They both are in slope-intercept form. So the first equation has a y-intercept at negative 5. 1, 2, 3, 4, 5. And it has a slope of 2, so we'll go up 2 over 1 for the rise and the run. And since it's linear, it has this constant pattern of up 2 over 1. And I don't know where they're going to cross, so I'm going to do a couple points in each direction from the y-intercept. So to go backwards, we'll go down 2 over 1, down 2 over 1. And if we need to add points, we'll add points. So first equation is graphed. Second equation has a slope of negative 3, so negative 1/3, and a starting point, a y-intercept at 2. So it has a y-intercept at 2, and we'll go down 1 over 3, down 1 over 3, and just to kind of get a good graph, we'll go up 1 and back 3. So this graph has a negative slope, and we are looking for what point they have in common. The lines intersect, they intersect at this one coordinate. So the solution to this is that coordinate. And that coordinate is 3, 1. So we're going to check it. Make sure that everything is good. So we're going to plug in these coordinates, make sure that they work they're supposed to satisfy both equations. We're going to verify that that happens. So the y value is 1 and the x value is 3, so we'll plug that in. So it'll be a 2 times whatever x value is minus 5, and if this works, this should add up to 1. So this is 6 minus 5, 1 equals 1. First equation checks. Second equation, our y value is still 1, negative 1/3 times the x value of 3 plus 2. Negative times a positive is negative. 1/3 of 3 is 1 plus 2, and this adds up to 1, so it checks. So our solution is 3, 1, and we're going to classify it. So, since we have a solution, it is consistent, but we only have one solution, so it's consistent and independent. All right, our second equation is y minus x equals 3 and negative 2x plus 2y equals negative 6. So I'm going to get both of these two ready to graph, put them into slope-intercept form, and we'll graph them. So first equation, x minus y equals 3. We want to put it in the slope-intercept form, bump the x over. To do that, we will subtract x on both sides, and that will leave us with a negative y equals negative x plus 3. To get rid of the negative attached to the y, we're going to divide every term by negative 1. So y equals, negative divided by a negative is a positive. Positive divided by a negative is a negative. So our first equation is y equals x minus 3. Our second equation takes a little more work to get ready to graph. First thing is we'll move the x over, so we'll have to add 2x to both sides. So we'll have a 2y equals positive 2x minus 6. They're not like terms. Divide every piece by 2 to get y by itself. So y equals x minus 3. So before we graph them, we have the exact same equation. So visually, we have the same line. So we have to understand what that means as far as the solution goes. So let's go ahead and graph. Has a y-intercept, both of them have a y-intercept of -3, and they both have slopes of 1. So we'll go up 1, over 1, up 1, over 1, up 1, over 1, up 1, over 1. So it's one graph. That means any coordinate works. So as long as it's on that line, it's going to satisfy both equations. So our solution is infinite solutions. But you can't just take anything. So it has to make sure that it satisfies, it's on the line, so it has to satisfy the equation. You can't just randomly take any coordinate. So it's infinite solutions of, and this is the point where we just grab one of those equations, maybe the easier of the two equations. X minus y equals 3. You could grab that equation, or you could grab any of the equations once they've turned into slope-intercept form. They're the same. So this represents our solution. So we'll classify it as well, and then we'll check. So first question is, do we have a solution? Yes, we have an infinite solutions. So it is consistent. And we don't just have one solution that independent suggests, we have infinite solutions. So it is consistent and dependent. And if you look back, you might start to get good at recognizing when this kind of a situation is going to happen, where the second equation is exactly a perfect multiple of the first one. If you take every single term and multiply it by -2, you get this exact same equation out of it. So one equation depends on the other. Check it. We'll grab one coordinate, ideally not the y-intercept. So let's say we'll grab that coordinate. And we're going to verify that that coordinate works. So it's -2, -1, 2, 3, 4, 5. So we're randomly grabbing a point, and we're going to verify that it actually works. So our coordinate is -2, -5. So our first equation is x minus y. So -2 minus -5 is supposed to add up to 3. -2 minus a negative will actually become a positive, equals 3. And that adds up to 3. 3 equals 3. So it satisfies the first equation. Doesn't guarantee it satisfies the second, so we have to check. So you have a -2 times -2 plus 2 times -5 is supposed to equal -6. So -2 times our x value plus 2 times our y value is supposed to add up to -6. This multiplies to a +4. Positive times a negative is a negative. 2 times 5 is 10, equals -6. 4 minus 10, you're subtracting more than you have, so you're going to end with a -6. And it checks. All right, last equation is, we're going to have equations of 2x minus y equals 4 and 6x minus 3y equals 9. So we'll start to get these two ready to graph. So 2x minus y equals 4. Try to get y by itself. We'll bump the x over, so we'll subtract 2x to make that happen. And we'll have a -y equals -2x plus 4. And we'll divide each term by a -1. So y equals, a negative divided by a negative is a positive. 4 divided by -1 is a negative. So our first equation is that. Second equation, 6x minus 3y equals 9. We'll bump the x over by subtracting it to the other side. So negative 3y equals negative 6x plus 9. To get the negative 3 away from the y, we'll divide every piece by negative 3. So negative divided by negative is a positive. 6 divided by 3 is 2. Positive divided by negative is a negative, and 9 divided by negative 3 is 3. Negative 3. So those two are ready to graph. And just looking at them, they have the same slope, but they have different y-intercepts. So that is giving me an idea that they're going to probably be parallel to each other. Same slopes, different y-intercepts. So one's going to go down 4, up 2 over 1, 2 over 1, 2 over 1, down and left, 2 over 1, down 2 over 1. So first equation looks like this. Second equation is going to be the same slope, but it's going to have a different y-intercept of negative 3. And then up 2 over 1, up 2 over 1, up 2 over 1, down 2 left 1, down 2 left 1. And they're going to be very close, but they are parallel. So, solution-wise, what does that mean? Solution is always about what point or points will satisfy both equations. So what do they have in common as far as coordinates go? Not as far as slopes and y-intercepts or anything, but as far as coordinates. They don't share anything. They don't have anything in common. So that is a no solution. And there's nothing to check on a no solution, because you're not able to figure out a point that's supposed to work for both. And we'll classify it. So consistent again meant that we had a solution. We don't. So if consistent means we have a solution, inconsistent means we don't have a solution. So we do not have a solution. It's known as an inconsistent system of equations. And that is solving systems of linear equations by graphing.